Welcome to the Moldex3D Advanced Tips and Tricks. In this session, we're going to be talking about mold component import and meshing. And after this session, you should be able to import multiple mold components to represent the real mold situation, learn organizational tactics to make the procedure more smooth, and apply the best practices for meshing to a larger system. All right, once I have the project created, now I can select my molding type, which is obviously injection molding here, and then we'll start importing our geometry. So what I'm going to look for is that consumer folder that I asked you guys to download. And in that folder, I've conveniently, under the CAD data subfolder, I've thrown a multi-import section in there. And that will hold all of the step files that we're going to import for this exercise. And they're more or less named as they should be. So we have the parts, we have the runners, we have the cooling system, and then we have some inserts that we're going to bring in. So we have really everything we would want to import from a real molding scenario. Ultimately, we're going to try to simplify our mold design so that we're only simulating the critical components. So for example, things like the ejector pins, slides, even the mold blocks themselves don't necessarily need to be imported into Moldex3D because those components, as far as the simulation is concerned, those components are only going to be used for heat transfer. As long as the heat transfer properties are the same between all these components, then they could really just be considered one block of material. So if anybody's run Moldex3D through our trainings or anything like that, we just recommend you to put a mold base, which is just a box, around your system. And that box is where all of the heat transfer is going to occur. Like I was mentioning, any component that's the same material can really be assumed to have the same heat transfer properties, and therefore we don't really need to model in those components directly. If we were to model in all of the components of the mold, then we would get an extremely large element count, which is going to lead to extremely long computations. And we want to make sure that we're arriving at the best trade-off between exact model that we want to get into the simulation and computation time. So we want to be able to compromise between those two and trade off to make sure that we're arriving at the most optimal conditions. So when we're talking about modeling a more complex system in Moldex, we're really only going to be modeling the components that are different materials from the main mold base, which is around everything. Now, just like any other model, we always recommend step files for our geometry objects, things like your parts, your inserts, even runners and water can be brought in as geometry objects. Now, our recommendation is usually to bring these in as lines, but sometimes the runner system and the water is too complex to be simplified by lines, and it can be a little bit tedious sometimes to draw those lines. So if you want to, you can bring those in as geometry objects. And towards the end of this session, I'm going to show you guys the most efficient way to convert your geometry system to a series of lines. So that's another thing we're going to be going over. All right, so I'm going to do this in stages. The first thing I'm going to do is bring in my parts. That's the first step that I always do to make sure that I'm modeling everything accurately and that ultimately I attribute or assign everything as the correct component. So I'm going to import the parts.stp. All right, the part geometry itself is quite simple. It doesn't have to be. It can be as complex as any other simulation, but we're just going to use this nice simplistic model. Now, whenever I import any geometry, the thing to keep in mind is that Moldex will not make any assumptions for what this geometry is supposed to mean for the simulation. So for example, this attribution is currently set to none. And there's a shortcut I can use. There's actually a couple of shortcuts I can use to attribute these objects, and I'll show you all of them real quick. First of all, I can box select everything and right-click Edit Injection Molding Attribute. That's the first shortcut. The long way, I'll say, the main procedure is up using this button here, using the attribute button, but there's many shortcuts. The first one is just box selecting everything, right click, edit injection molding attribute. If you're only attributing one object, you can actually just double click on that object. So for example, if I just double click on this object, you'll see that it goes straight to my attribute wizard. So that's a nice little advanced tip there. And then also, it seems not a lot of users know about the model tree. So I want to really explain the model tree, as we're going to be using that in very high detail for this session. And you should be using it as much as possible, as it correlates a lot with some of the better CAD systems out there. So over here on the top left corner of my screen, underneath the main ribbon, is this little toolbar. The tree that's selected right now is the first button in this toolbar, and that's what we call the project tree. So that's where all of the runs are going to be stored and all that good stuff. So that's what we should be seeing right now. The second button is what we call the model tree. So the model tree will hold all of the objects from the simulation, and you'll see that as I hover over the different objects, they highlight in orange on my model. Now, if I click on any of these, you'll see that it'll actually highlight that object. And if I right click on that, I have a series of actions that I can do. I can either delete it, I can hide it, I can, and the shortcut that I'm going to show is you can attribute it. So you can either do each of these individually if you want to, or you can actually just highlight the main section here where it says non-attributed. Then I can right click on the main section and attribute, and that will allow me to attribute all 8 of these objects at once. Now, right now it seems kind of trivial because there's not really any other objects that are intersecting or overlapping these parts or inhibiting us from selecting. But once we start to get more and more components, selecting the objects from the model tree is going to be extremely convenient. So that's a tactic and a tool that you want to adopt in your main modeling scheme. When you start to import objects into Moldex, you really want to use the model tree, as it's going to be the most efficient way to attribute all these different geometries. All right, so you'll see that the default attribution is none. I'm going to choose the part, and you can see all the different attributes under here. We'll be going through pretty much all of the main ones as we import the different objects into Moldex. All right, so once I attribute as part, you'll see that the parts will, or the geometries here will have a different color. Each attribution in Moldex has a different color associated with it, as many of you already know. Now, once I've attributed these parts, I can start bringing in additional components. So for example, I can go back up to my main ribbon here and click Import Geometry. You'll see that it actually brings us to the same exact location where we imported our last model. And that's actually really important. So when you're exporting your models from your mold design, you want to put them into the same location, as it allows us to, it just makes it easier for us to import them one by one, or you can actually import these as groups as well, as we'll see in a few moments. I like to import them attribute by attribute just to make it a little bit easier to select everything. But it's up to you. As we go through this, you'll see that there's a lot of, there's not one right way to do things. You can make things more efficient or more streamlined for how you normally do things. So I'm going to bring in the second component here of my melt system, which is going to be the hot runners. I've only brought the hot runners up to the top of the drops, really. I didn't bring them all the way up to the sprue. And we'll see that in just a moment. We see that they're just kind of a big blocky object. And most of the time you will want whenever you're modeling a hot runner system, you will almost always want this runner system to be complete. You won't want any sort of simplifications like this. I just simplified this to make it a little bit easier for us to go through the process. But in all realistic scenarios, you would definitely want these drops to be connected into one system. Now I can do the same thing that I did for the parts. I can highlight the non-attributed section, right-click, attribute. You can just see how easy this is, rather than having to go and manually click each one of these and then right-click, edit injection molding attribute. I can just do it all from the model tree, and it makes things more streamlined. I'm going to call these hot runners because they were hot runner drops onto the onto this tab on the part here. All right, and because all 8 of these are presumably the same cavity, there's no valve gate controls or any hot runner controller IDs, so we can just kind of skip over that section. So we can just attribute them as hot runner, press the green check mark, and then we can bring in our next component. The next component we're going to bring in is the inserts. So I'm going to import geometry. Again, it'll bring us back to the same place. And if I hold shift, this works for any sort of file explorer interface for the most part. I think there's maybe a couple of exceptions out there, but if I hold the shift button, I can multi-select these step files. And if I cleverly name them so that they're alphabetically oriented, or if I can sort them in some way or another, it makes it a little bit easier. I can also use Control to select multiple files here as well. So just a little bit of a tip. So I'm going to actually select all 4 of these at once, and I'll click Open. Like I said, I like to do these attribute by attribute, but you could theoretically bring in all of the objects at once. All right, and this will take a few moments just to get everything in here. You can see this non-attributed list kind of showing up here. You can actually see down here at the bottom left corner, it shows us what's actually happening. So you can see that it's importing all of these objects. We don't really want to start clicking on the screen or anything like that. It can cause Moldex to go delinquent. It doesn't mean that it's going to crash or anything like that. Most of the time it does come back. But you just want to be a little patient, make sure that everything gets into Moldex before you start clicking around. All right, so we can see that it's still importing. One other note is I have separated these out as different files, but you could theoretically actually bring them in as one single step file. If they're separated when you export them from your CAD system, they'll be separated when you bring them into Moldex3D. So theoretically, all of these inserts, for example, rather than being 4 separate step files, I could actually have all of these inserts as one step file, and they would come in all as separate objects. All right, so now I have a bunch of non-attributed objects. You can see these gray ones. I usually like to get the attributed objects out of the way. So I'm going to click the radio button next to my part attribution here. So you can see the part main header has a little button next to it. I'm going to turn both of those off, so that makes it a little bit easier to see everything and reduces the amount of clutter that's occurring here. So what I'm going to do, actually, you could see that through the file names. I didn't really point this out. But you can see that through the file names, there's 2 different material groups that we're going to be assigning here. So one of these insert groups is going to be 420 stainless, and then the other one's going to be an aluminum insert. Now you could you could designate those as you will, and you can import them separately to make sure that you have your material group separated and all that good stuff. But just to show you that you can import these as the same material or the same step file, and you can import multiple step files at the same time. We just brought them all in at once. All right, the 2 material groups in this situation are going to be separated by the outer inserts and the inner inserts. So we'll just to show you real quick what that looks like, I'm just going to hide this object here. And you can see that there's a couple of inserts on the middle. And these inserts really just kind of help to form the part ultimately. But they are a different material from the outer inserts, and the outer inserts are a different material from the mold that will go around everything. So that's just something very important to note. All right, so we're going to attribute these separately. We're going to attribute the outer inserts first, and then we'll attribute the inner inserts. Just because they're different materials, we want to make sure that we keep the material groups separated. All right, so I'm going to hold the shift button, and that will allow me to multi-select. You can see that it's just adding to my selection. Should be 16 ultimately. And then I can either right click on my model tree, or I can just right click on the model itself and then edit injection molding attribute. And these are going to be assigned as mold inserts. Now there's two different types of inserts we have in Moldex3D. There's a part insert and a mold insert. So part inserts will always come out of the mold with the part. So they'll be ejected as an inclusion into the part geometry, whereas the mold inserts will be held in the mold. So the mold inserts will never be ejected. They're just there for thermal conditions. So that's exactly what these are. They're just mold inserts. So we're going to assign them as such. The material group name here is going to be very important. If I were to assign these mold inserts, hide them, and then assign the rest of my non-attributed objects as mold inserts, they're all going to be included in the same material group. So I won't be able to designate in my material selection which insert is supposed to be which material. So I want to make sure to assign my material groups. I just want to make sure that I assign my material groups appropriately. So when I'm assigning my mold insert, I'm also going to add a material group name. I can name this whatever I want. In this case, I'll name it, I believe these are the aluminum inserts. So I'm going to just name this aluminum, and then I can actually change the color of this group as well. So I can change it from yellow, which is the default, to maybe like a nice bright pink. I'll press OK. And then I'll select that material group. That's very important because even though you create the material group, you're not necessarily saying that these objects are supposed to be in that material group. You're just adding it. So you want to make sure to select that material group under that dropdown as well. All right, so we have that nice bright pink color there. And then once we assign all of that, we can press the green check mark. You can see that those now show up under my model tree as a mold insert with the subgroup aluminum. All right, I can now hide those mold inserts because I've assigned them, and because they show up separately now under my model tree, I can hide them, just leaving behind the rest of my mold inserts. So now, because these are the only mold inserts left, I can either box select these, I can select them from my model tree. Either works. Right click, attribute. I'll assign these as a mold insert. And I'm going to add another material group. So I'm not going to use this aluminum because this is the material group that I've already used, or that I've already specified. So I'm going to add, and we'll call this 420 stainless. And I'll make the color, I don't know, green. You just want to make the color such that it doesn't blend with any of the other attributions. So usually like pink, green, brown, red. Those are the four that I usually use. Yellow also does work. It's just sometimes it's a little bit tough with our selection. You can see that our selection makes all of the feature lines yellow. So yellow is kind of tricky to designate which objects are selected when you're dealing with that group specifically. So I'm going to use green here. Okay, and then I'll select it under this list and press the green check mark. All right, so there's one last thing that I'd like to bring into Moldex, and that's the cooling system. So I'm going to go and import geometry, and then I'm going to take both of my water. There's a fixed water and a movable water. Those will just be the A and B or core and cavity sides. And I'll import those as well. And again, there's nothing wrong with bringing them all in at once. As long as you know which components are which, you should be able to discern in Moldex, where these objects are actually located. It's just from a selection standpoint, sometimes it can be a little bit tricky to select all these objects independently. So it just makes it a little bit easier for us if we can bring them all in as one, or bring them in as separate attributions. All right, so now I'm just going to select all of these. I can either use a box select like this, You can just select all 8 of these cooling channels. There's 8 cooling channel systems here. You can use the Shift Select to select all 8 of those. Right click, edit injection molding attribute. You could also use the trick that I told you earlier with the model tree. We're going to assign these as cooling channels. All right, nothing too complicated about that. Just assigning them, telling Moldex that this is where our water is going to flow. Now you'll actually see, and this is actually something that comes up quite commonly. You actually see that these cooling channels have a little bit of a ghosted surfaces. That's what I call them. These surfaces are actually there because this feature line is here. The surface is actually there, and it will mesh correctly. It can be a little bit scary sometimes to see this sort of thing happen. To clear this error, you could actually just run these cooling channels through CAD Doctor, and it would just bring those surfaces back as you would expect them. So you can run them through CAD Doctor. Sometimes this is just like a translational error that happens with Moldex3D occasionally. Not very often, but sometimes. So I'm just going to leave them as they are right now. If you do want to run them through CAD Doctor, please feel free to do so. All right, so now we have all of our objects in our modeling system, except our model tree is extremely long. Look at how many objects we've brought in. Sometimes it can be a little bit clunky to have everything shown like this. So you can see that each poly surface is its own row in this table. And scrolling up and down can be kind of a pain, especially when you're just trying to turn off and on certain attributions. So there's a little bit of a trick. It's not too advanced of a trick, but if you go up to the model header, so the very, very top of this model tree, if I right click on the model header, you see that it selects everything, and there's an option to collapse the sublayers. So this will allow you to just kind of get everything compressed so that you can see everything a little bit easier and a little bit more readily. I can also expand my mold insert to have my 2 different attributions showing up. So whenever I have a sub attribution like this, mold inserts have this, part inserts have this. There's a couple of other attributions that I'm definitely missing that have this sort of designation. Whenever I have a subgroup like this, I usually try to expand them after I collapse everything. Now that we have everything attributed, I'm going to turn everything on. There's a couple of ways to do this. You can either highlight any object, right-click, show hidden. That will show everything. You can also just go through your model tree, and you can just turn everything off and then turn everything on. So you can just use the header radio button there. All right, cool. So now we have our entire system imported into Moldex3D. And remember, this is only the, I'll say, quote unquote, important components, or components that are of different material than the mold base that surrounds everything. So just keep that in mind. This is kind of this would be a simplified version of the actual mold. You can see that there's some ejector pins that are trying to go down through here. You could have numerous surfaces on here, but you really only want to model the objects that are a different material than the mold base. All right, so the first thing we're going to do here is assign the melt entrance boundary condition. So the melt entrance is just going to tell the simulation where the plastic flow is going to start from. In this case, it's just on the top of each of these 8 drops. So in this specific example, there's going to be 8 melt entrances. Most of the time when we're doing this sort of a simulation, we want the runner system to connect up all the way to the barrel. So we would have all of these kind of connecting up to one single point. In that case, you would only have 1 melt entrance. And Moldex is actually really smart at selecting where the melt entrance should be automatically for you. So you don't have to go through and specify the face on each of these, all 8 of these objects. You can actually just click the melt entrance button. You'll see that it'll actually just put a melt entrance on top of all 8 of these objects. And it knows that because the other end of this is connecting to the part attribution. So it recognizes that and says the other side of this runner object should be where the melt entrance is located. It's actually really smart in that regards. All right, so now that we have our boundary conditions set for the melt system, now we can start dealing with the cooling system. So right now, we just have a cooling channels, but we don't have any sort of way for the heat to get from our part, or ultimately, I guess, our inserts, since the inserts are almost completely encapsulating our parts right here. There's no way for the heat transfer to occur between our inserts and the cooling channel. So we need to have a mold base which will facilitate that heat transfer. So I'm going to go to the mold base button here, and I'm just going to create a mold base automatically. All right, so there's a couple of things that the mold base does automatically for us. First of all, it recognizes where all of these cooling channel ends are located, and it puts those ends directly on the mold surface. And that is extremely important. Every cooling channel entrance and exit has to be on the mold base plane. We can't have coolant inlets and outlets internal to the mold base because the simulation will not be able to recognize that that's where the coolant should start flow from. So something like this over here is kind of a drill hole end, I'll say. So the drill hole kind of continues all the way to here. And that's okay for the simulation, but for the entrances and exits, or the inlets and outlets, we need those to be on the mold base surface. That's one of the most crucial parts of this whole modeling process, especially when you're trying to model everything from your mold design. I guess first of all, I'll say that this length dimension is kind of locked. So this, if I rotate around a little bit more, you see that we have a length and a width dimension. We really can't modify this length dimension without it pulling the surface of the mold base inwards. Because this mold base is based on the center of our model, it will just kind of pull them in symmetrically about this box. And for that reason, it would pull these surfaces off the mold base wall. That's definitely not something we want to do. So the L dimension here, in this case, will be locked. We can't really do much about this, but we can change the width, and we can also change the height if we wanted to. So the width would be this dimension right here, and then the height could be modified from the second menu. If I click on the blue arrow at the top here, I can access the height dimension. Now, honestly, the reduction of your mold base isn't going to do a whole lot to your simulation. And the reason for that is because the amount of heat transfer that's actually occurring out towards the boundaries of your mold base is negligible with respect to the amount of heat transfer that's occurring between your inserts and your cooling channels. Most of the heat transfer is not going to get past your cooling system, ideally. So the mold base elements that we have out towards the boundaries are really not going to do all that much. You'll actually see that they're very large, and cutting off this volume that I just did isn't going to impact the simulation at all, really. So you could keep the mold base boundary as it was. You could keep it a little bit larger, reducing it, even trying to make it closer to what it is in reality. You can. Like I said, some of the dimensions are going to be fixed, especially exactly the ones that are connected to the mold base boundary by default. But it's not the end of the world if you can't get the dimensions exactly as they are in your mold base, because the amount of heat transfer occurring out towards the boundary is not all that much. Once I have the boundaries, once I have the dimensions set, I can press the green check mark. And now we have a nice boundary around everything. The last thing that we need to do, the last boundary condition that we need to set, is where the coolant is supposed to enter and where it's supposed to exit. So we just need to tell the simulation where these entrances and exits are supposed to be. And we do have an automatic function for this, the inlet outlet function. I don't really like to use it just because it's a little clunky in my opinion. You can certainly feel free to try it if you'd like. But I usually just go for a more straightforward approach with the add inlet and add outlet. All right, so that's what I'm going to do in this situation. I'm going to use add inlet, and I'm just going to put an inlet on all 8 of these cooling channels. The most important thing to note is that the inlet has to be in the center of this surface. So we need to make sure that we're using the center snap, and we're going to snap to the center. I'm going to hover over the feature line around the circumference of this coolant inlet, you'll see that center snap pops up, and it places a dot right in the center. And that's exactly what I want to see. So I'm going to do that for all 8 of these. Remember that you need to hover over the feature line. Don't try to like approximate where you should go in the center, because that's not where the center snap is going to be based on. All right, and once we have all 8 of those, this is little windows here, I can just escape out of this window and it'll place all of the boundary condition arrows for me. And you can see also in my model tree, it's created this nice little boundary condition section. All right, I'm going to do the exact same thing to my outlets using the add outlet function. So that is all of the boundary conditions that we need to set for our system. Like I mentioned, all of the other components of our mold are really just going to be contained as a part of this heat transfer box. So all of the heat transfer properties should be the same for the other components. Things like ejector pins, slides, any sort of moving components are usually going to be the same material as the mold base. And for that reason, we don't really need to model them in, but they can just be kind of considered an inclusion into this mold base boundary. All right, so now that we have all these geometry objects attributed and modeled properly, now we can move on to the meshing portion. So the meshing portion is actually quite straightforward, but there's a couple of steps that really need to be pointed out. So I'm going to go over to the mesh tab. And the first thing I'm going to do, because all these objects are geometry objects, I need to create a surface mesh around all of these objects. And from that surface mesh, we can then create the solid mesh. So because I need to create a surface mesh, I need to define the template, which is going to be our node seating, as many of you probably already know. And this part is really, this is probably the most important part of modeling a complex system like this. We want to obtain a really good surface mesh on our part. Whatever surface mesh that, or whatever node seating that is, we're going to apply to the entire system. And I'll explain why that is in a few moments. But what I'm going to do here is I'm going to hide everything except for my part. And we're going to define the node seating of the part first, and then use that seating to apply to everything else. All right, so I'm going to box select all 8 of my parts here. You could also just select them from the model tree as well. And I'll press the green check mark. Now, if any of you guys have joined one of our standard series trainings, then you'll know the node seating technique that we use. I call it the Goldilocks technique, where I zoom in the part so that it fills up the whole screen. I'm going to apply the default node seating. It's actually not bad. But I'm going to decrease my node seating until I get about 2 to 3 nodes width of space in between each of the nodes. All right, and you could make this a little bit more coarse if you wanted to. If you can preemptively kind of figure out that you're going to have a huge mesh element size or a huge number of mesh elements, you can make a little bit of a sacrifice in this and make the node seating a little bit larger. Sometimes I do that preemptively just to make sure that my computation time is reasonable. Again, we're always trying to make an optimal trade-off between computation time and modeling accuracy. So we can always make that sacrifice if we can anticipate that our simulation time is going to be very long. In this case, I would say that you could stray away from this small of a node seating a little bit, and you could probably use the default. The default wasn't horrible. Usually want it to be a little bit more recognizable of a number, just so you can remember it a little bit better. So I'll just decrease it to 1. And this is the node seating that we're going to use for every other object. And you can see how that is going to impact our total modeling, or ultimately the final element count that we're going to get is going to be pretty large. So I'm going to press the green check mark. This will send me to the manual node seating. I don't need to do anything there. So I'll just press the green check mark one more time. All right, from here, now I'm going to assign that 1.0 mesh size to all of my other components. So I'm again going to click my node seating button. So in this case, it'll just be the hot runner, all of our mold inserts, and the cooling channels. Press the green check mark. And it'll ask me to reset the initial mesh size. I'll just say yes. And we'll see that it kind of just pops up the mesh size that we had on there originally, which is 1. Apply. And we should be able to see, it doesn't give us that, that message where our element count is going to be over 1 million. And that's because we didn't include the mold base. So we can see that the mesh size is rather fine. And that's, like I said, it's just unfortunately a consequence of this more complex system. We always have a higher element count and therefore longer simulation times. If you want to decrease your simulation time, the best suggestion is to reduce both your runner system and your cooling system to lines. The number of elements that are created in a line-defined cooling system versus a geometry cooling system is going to be much, the line-defined system is going to have a much lower element count. So that's probably my best suggestion for getting around this sort of really fine surface mesh. All right, so I'm going to press the green check mark here. And we don't have to do any manual node seating. We know that everything is pretty well refined, so we don't really have to do anything manual here. So I'll press the green check mark. All right, now that we have all of our I guess the template of our surface mesh set up, now we just have to define our solid mesh parameters, and I'll just go through those real quick with everybody in case someone didn't join our trainings recently. We have changed our best practices in the last couple of versions. So first of all, for the part, we're going to use a 5 layers BLM, and our boundary layer offset ratio is 3. Part insert, we're going to use pure tetra. We don't actually have any part inserts here, so that's not going to matter. For the runner, we're going to use the same as the part geometry, so we're going to use 5 layers BLM and a 3 offset ratio. For anyone that just installed, you might have this automatic function selected. I'll ask you to just use the manual for now, as the automatic is kind of in its beta form. Cooling channels will be 3 layers BLM, and we're going to try to squeeze down the boundary layer section as much as possible. Use a 0.2 offset ratio for that. And then for the mold inserts, this is actually going to be quite important. I believe the default is pure tetra, and we want to make sure that it stays that way. So pure tetrahedral elements are actually very good at approximating heat transfer, and they actually end up decreasing our overall element count versus something like the boundary layer mesh for mold inserts specifically. Now, if we're looking at something like the part, we want to make sure that there's enough layers to the part to be able to calculate or to be able to simulate the plastic flow. But because there's no flow going through our mold inserts, we don't need as many layers, and therefore we don't need as many elements for our tetrahedral mesh. So the tetra elements are going to be much more preferred in the inserts. We don't actually have any curves, but if you are interested in the best practices here, for runners, we just use the default 4 inner, 5 outer layers. And then for cooling channels, we also just use the default of 2 inner, 3 outer layers. All right, so now that we have everything set correctly, now we can actually go and start to mesh this guy. So there's a couple of, we've set everything correctly. So the only thing left really is to make sure that we generate this patiently, I guess is the best word for it. It's very easy to get frustrated when it doesn't go very quickly, especially when you're used to just meshing like the parts, for example. The entire system is going to take much longer to mesh than just the part or maybe a more simplistic system. So, for example, the surface mesh is actually going to go relatively quick, but once we start getting into the solid mesh, especially the solid mesh of the mold base, this is going to take quite a long time. Actually, for this model, I believe when I did this the first time, the mold base took about 30 minutes to 45 minutes to generate. So you really have to be patient. If you need to, just do this over lunch, or do this after when you're about to leave for the day, and when you come back, you'll have the mold-based solid mesh generated. So just a quick note, just be a little bit patient with the mesher for these complex systems. So I'm just going to focus on the service mesh. Like I mentioned, the solid mesh generation is quite straightforward. It's just it just takes a little bit of time. So I'm just going to focus on the service mesh, make sure that we can get everything generated correctly here. So I'm going to select my service mesh. You can see that I put this little tack here. The tack just means that even if the service mesh is perfect when it's generated, the mesher is going to stop after this section. So I'm going to put my little tack here, and I'll click generate, and that will generate my service mesh. So you'll see that it's going to start from my parts, and then it'll move on to the other components like my runner, and you can actually see the sequence here. It'll go part, runner, mold insert, and then cooling channels. All right, so we can see the service mesh, the initial service mesh is almost done. And once the service mesh is done, it's going to go through a procedure called fix size gap. We should see that in a few moments here. Or maybe it'll tell us if there's any sort of mesh problem first. All right, so we get this little error here that says unusual interfaces detected. We can either continue the process or terminate the process and check it. This will always pop up whenever you have a mold insert object. And the reason for that is because Moldex3D does not match the service meshes between the different objects. So for that reason, whenever there's a fillet, or whenever there's a chamfer, or even like a hole that doesn't appear on the part, for example, there's always going to be an unusual interface there, and Moldex will tell you about it. And the cool thing is, we don't really care about these unusual interfaces because Moldex3D has a perfect non-matching mesh now. In previous versions in R16, we could not handle mold inserts being non-matching. So that's a huge improvement that we made into R17. That's what makes this whole process possible, is that we can have non-matching mesh between mold inserts to mold inserts, from the part to the mold insert, from the mold base to the mold insert. Everything can be non-matching, and it's not a problem. So for that reason, we can click yes here. We can say yes to continue the process, and nothing should go wrong here. So in this case, it looks like the mesher liked me today. Maybe it's because I put a little bit finer of a service mesh on here. But in my case here, you can see the service mesh generated perfectly without any sorts of issues. Now, occasionally you'll get a problem, something like aspect ratio, or maybe you even get a size gap error. It didn't look like it showed up here. It's because I modeled everything with the same mesh size, which should happen most of the time. You shouldn't always have that size gap issue, but sometimes you'll get that problem. And size gap basically just means that even though these two objects aren't lined up one-to-one, they might look like it here, but they actually are not. The interface between the two are going to be completely different. But if the surface mesh size is much different from the mold insert to the cooling channel, for example, there needs to be some sort of reduction that's done. It basically just reduces the larger surface mesh. It divides all the elements until the mesh element size is more comparable to the object that they're connecting to. Like I said, from the surface mesh, it's really quite simple or quite straightforward to generate the rest of the solid mesh. The surface mesh is really the tricky part. And as long as you go through the process like I went through here, you can see that even for a pretty complex system, I would call this relatively complex, we actually get a perfect surface mesh right out of the gate. And if you follow these practices, that should be probably anywhere between like 70 to 90% of the time should be, you shouldn't have any issues. Thank you for watching the Moldex3D Advanced Tips and Tricks. We'll see you next time, and go beyond simulation with Moldex3D.